Now, base of calculus is limits, continuity, and differentiability. If any student want to study calculus, first he should know about limits of a function, continuity of function, and differentiability of function. In this video, I am going to cover limits, continuity, and differentiability. In limits, first you should know left hand limit. Left hand limit, for example, if any function f(x) is given as x square plus 1 and x tends to 2 minus 2 minus means value of x is something less than 2 but nearest to 2 means x tends to 2 from left. For example, for different value of x we can find different value of fx. X equal to 1.9, fx we can write calculate 4.61. Similarly, continue and increase the value of x, fx also will increase. If x is 1.999, then fx you can write as 4.996. It implies if x tends to 2 from left, then fx tends to 5, which is known as left hand limit. And we can write this as limit x tends to 2 minus fx equal to LHL equal to 5. This is the left hand limit. And right hand limit, same process. For the same function I have taken x tends to 2 plus means x tends to 2 from right, means value of x is greater than 2 and nearest to 2. For example, x equal to 2.2, fx you can calculate, 2.1 again we can calculate, and continue to decrease the value of x, fx will also decrease, and if x is nearest to 2, fx will be nearest to 5. It implies x tends to 2 from right, then fx tends to 5 from right also, and which is known as right hand limit of function, and denoted by RHL as limit x tends to 2 plus fx equal to 5. And also you can say right hand limit exists at x tends to 2. Now limit of a function means if left hand limit and right hand limit at a point equal, then we can say limit exists at that point, and in short form we can write limit x tends to 2 fx equal to 5. Means now we can define limit of a function as a function fx tends to k as x tends to a if and only if both the limits left hand limit and right hand limit exist and are equal to k. Means limit x tends to a minus fx equal to limit x tends to a plus fx equal to k, or left hand limit right hand limit in combined form we can write limit x tends to a fx equal to k. If there is no plus or minus sign, it is understood that both exist and are equal to k. That is the limit of a function. Now next, some identities and limit of function. If limit x tends to a x power n minus a power n upon x minus a, if any question given this type directly you can apply formula as n a power n minus 1, or limit x tends to 0 sin x upon x equal to 1, or limit x tends to 0 tan x upon x equal to 1. These three are basic identities and limits. Then next, continuity of a function. Continuity means there is no break in the curve of function at a point, then we can say function is continuous at that point. In other words, you can say if limit exists at a point and equal to value of function at that point, then function is continuous at x equal to a or at that point. Limit extends to a if x equal to a. Means if left hand limit equal to right hand limit equal to value of function at that point, then you can say function is continuous at x equal to a or x equal at that point. Or graphically you can understood it as if you draw the graph of a function at any point, if curve of function not break, it is continuous, then you can say function is continuous. And discontinuity, the function is said to be discontinuous in following cases. First, fx is not defined at x equal to a. For example, if fx equal to 1 upon x, fx equal to 1 upon x, if we put x equal to 0, then value of fx will be 1 upon 0 and 1 upon 0 not defined. It implies function fx is not defined at x equal to 0. Or if we take function 1 upon x minus 2, 1 upon x minus 2, here at x equal to 2 function is not defined. If at any point function is not defined, it implies at that point function is not continuous or discontinuous. Second, if both the limits do not exist or any one, means LHL does not exist, RHL does not exist, or both do not exist, then you can say function is discontinuous. Third situation, if both limits exist but not equal, then also you can say function is not continuous or discontinuous. Means left hand limit not equal to right hand limit. And fourth case, if both the limits exist and equal but it is not equal to value of function at that point, then also we can say function is discontinuous. So there are 4 cases, so easily we can check function is discontinuous or not a continuous function. Now next, continuity of a function in the given interval. If open interval a be given, open interval means value of x is greater than a and less than b. AB is not included. The function is said to be continuous in open interval. It implies it is continuous at every point in open interval AB. And in closed interval, it is said to be continuous. It implies again it is continuous in open interval, but at end points A and B, at a right continuous means right hand limit exists, and at B left hand limit exists, then we can say function is continuous in closed interval AB. Here easily you can observe at x equal to a, right hand limit equal to value of function at x equal to a, and second point B, the left hand limit equal to value of function at b. Remaining all points between a and b, function is continuous. Then next, derivative of a function. First, limits completed, continuity. Now differentiability, and before differentiability you should know what is derivative of a function. If y equal to fx is a function, then y plus delta y, x plus delta x. Y equal to fx given, it implies x is independent variable and y is dependent variable, means value of y depend upon value of x. If there is change in x plus delta x, then y will also change. or delta y we can write as fx plus delta x minus y, and y means fx, put the value of y, divide by delta x and apply limit. Limit delta x tends to 0 means minimum value of a very small change in x, and which we can write as dy by dx. The limit delta x tends to 0, dy delta y upon delta x we can write as dy by dx, or which also we can write as f dash x equal to limit delta x tends to 0 f x plus h, or f x plus delta x minus fx upon delta x. Therefore, final result we can write dy by dx, or also same thing we can write ddx of fx because y equal to fx, or also same notation as y dash or limit delta x tends to 0 delta y upon delta x, or delta x tends to 0 fx plus delta x minus fx upon delta x equal to f dash x. All represent derivative of function or same notation. At any point, if we want to find derivative of function, f dash x calculated in place of x, write down c. You will can find derivative of function at x equal to c. Or also we can know the derivative of function at any point means slope of tangent of curve at that point is known as derivative of function at that point. If you draw the curve of any function y equal to fx, at any point you want to find derivative. Derivative represents slope of tangent at that point. That is derivative of function. One more thing you should remember. The process of finding derivative is known as differentiation. Generally, students confuse in derivative and differentiation. Derivative means slope of tangent at any point on the curve is known as derivative of function, and the process of finding derivative is known as differentiation. Now, next, differentiability of a function at a given point. If fx is differentiable at a point, it implies right hand derivative at x equal to a exist and finite. Right hand derivative means if you find derivative of function at x tends to a plus. Definition of derivative just covered in the previous slide. Same formula written. The derivative of function, a right hand derivative we can define as limit x tends to a plus means value of a is something greater than a equal to fx minus fa upon x minus c. Or in place of x we can write a plus h. You can observe here value of x tends to a plus means x is greater than a, and greater than a means take value of x as a plus h. Let x equal to a plus h, and h is very small quantity, or you can say h tends to 0. Then in place of x write down a plus h, fx plus a plus h minus fa upon h. It is known as right hand derivative. And left hand derivative, you can calculate limit x tends to a minus fx minus fa upon x minus a means value of x is something less than a, means let x equal to a minus h. In place of x write down a minus h, f a minus h minus fa upon a minus h minus a cancel out, minus h remains. And here what is h? H is very small quantity, or you can say h is equals to 0. Any function is said to be differentiable if left hand derivative and right hand derivative both exist and both are equal at that point. Means right hand derivative equal to left hand derivative at x equal to a. or you can say r f dash a. Right hand derivative also we can write as r f dash a means right hand derivative equal to left hand derivative at x equal to a. The left hand derivative, right hand derivative both defined and exist and both are equal to each other, then we can say function is differentiable at that point. Means at that point we can find slope of tangent of the curve. Now, question arises for the relationship between differentiability and continuity. Continuity represents that function is continuous at that point. It is not break. Curve of function is continuous. It is not break. It implies it is continuous. And differentiability means at that point you are able to draw a tangent. If at that point one tangent exists, only one tangent you can draw, then you can say it is differentiable. There is no corner point at that point. For proof, since fx is differentiable at x equal to a, directly you can apply formula. Left hand derivative, right hand derivative in combined form we can write this as limit x tends to a. Fx minus fa upon x minus a equal to f dash a. Make it as equation first. Also, if fx minus fa also we can write as fx minus fa multiply by x minus a upon x minus a. Then limit x tends to a equal to limit x tends to a fx minus fa upon x minus a, denominator right here and numerator as it is x minus a. Now open the bracket. Using property of limits, you will get limit x tends to a fx minus limit x tends to a fa. Limit x tends to a fa means fa. RHS, this whole value is f dash a into here apply limit a minus a 0 equal to 0 or limit x tends to a fx equal to fa means function is continuous. It implies if any function is differentiable at any point, we can say it is also continuous at that point. Now some solve example. Function given mod of x minus 3. We have to prove that it is not differentiable at x equal to 3. Method: find out left hand derivative. Left hand derivative by definition x tends to 3 minus fx minus f3 upon x minus 3. Limit x tends to 3 minus, in place of fx put the value x minus 3 minus value of f3, in place of x write down 3, mod of 3 minus 3 written here upon x minus 3. Mod of 3 minus 3 means 0, and in place of x tends to 3 minus means put x equal to 3 minus h, in place of x write down 3 minus h. Denominator again 3 minus h. Further simplify, h tends to 0, mod of minus h upon minus h, and mod of minus h is h. Limit h tends to 0, h upon minus h equal to minus 1. Left hand derivative at x equal to 3, after solving you are getting as minus 1. Now calculate right hand derivative. Same process. Limit x tends to 3 plus fx minus f3 upon x minus 3. Value of fx is x minus 3. Mod of minus f3 means mod of 3 minus 3. In place of x write down 3 plus h, because right hand limit we are going to calculate, where h tends to 0. Simplify, and after solving we are getting as 1. Left hand derivative minus 1 and right hand derivative 1. Easily you can observe left hand derivative not equal to right hand derivative. Means f dash 3 does not exist, or you can say function fx is not differentiable at x equal to 3. In this pattern, if any question given, you can check function is differentiable or not. Now, one more solve example. If function is differentiable, it is given at x equal to 1. You have to find the value of c and d. One more result you should know. If function is differentiable, it implies it is also continuous. If it is given function differentiable, means it is also continuous. For continuity, if a function is continuous, means left hand limit equal to right hand limit equal to value of function. Left hand limit extends to 1 minus fx. 1 minus means value of x is less than 1. If x is less than 1, then fx is x square. Write down x square. In place of x, write down 1 minus h. Apply limit, and you are getting 1. Right hand limit greater than 1. If x is greater than 1, 2cx plus d equal to 2cx plus d. In place of x, write down 1 plus h. Simplify 2c plus d. Since function is continuous, therefore left hand limit equal to right hand limit. Directly you can write limit exists are 1 equal to 2c plus d. Or also you can write the value of function at that point also equal. And if you calculate value of function, if x equal to 1, again you will get 1 square 1. Therefore directly we can write the left hand limit equal to right hand limit, means 1 equal to 2c plus d. Now check differentiability. First you have to calculate left hand derivative using formula. X tends to 1 minus fx minus f1 upon x minus 1. 1 minus means value of x is less than 1. Put fx x square minus 1 minus f1. If x equal to 1, that is 1 square 1. Next step, x tends to 1 minus means put 1 minus x equal to, simplify, then h square common and cancel out, and after solving you are getting left hand derivative as 2. Now calculate right hand derivative. Same process, 1 plus. If x is 1 plus means greater than 1, function is 2cx plus d, function written here, minus value of f1 is 1. Again in place of x, write down 1 plus h, simplify. Now already in equation first we have written 2c plus d as 1. 2c plus d write as 1, 1 minus 1, 0. Therefore what remains? 2ch upon h cancel out, equal to 2c. Since function is differentiable, means left hand derivative equal to right hand derivative, means 2c equal to 2 or c equal to 1. From equation first, 2c plus d equal to 1, put the value of c, so 2 plus d equal to 1 or d equal to minus 1. Therefore function is differentiable at x equal to 1 if c equal to 1 and d equal to minus 1. In this pattern you can solve the questions of continuity and differentiability. Now some questions, and before solving questions, some identities I have written here which you should remember. Differentiation of x power n is nx power n minus 1. Differentiation of trigonometry functions written. Sin, cos, tan, sec, cosec, cot. Differentiation of sin is cos. Differentiation of cos minus sin. Differentiation of tan is sec square x. And differentiation of cosec x minus cosec x cot x. Differentiation of sec x tan x, and differentiation of cot is minus cosec square x. For trigonometry functions, one more thing remember, the plus minus sign. If trigonometric function start with C, cos, cosec or cot, then its derivative start with negative sign. Differentiation of cos with minus sign. Differentiation of cosec minus. Differentiation of cot minus. In this pattern, you can easily remember which trigonometric function start with minus sign, its derivative you are going to find. Then next, if sum of two functions given u plus b, then ddx of u plus b you can write du by dx plus dv by dx. For u minus b, same result, du by dx minus dv by dx. If product form given, the product rule you should remember. First function differentiation of second plus second differentiation of first, and for quotient rule or division rule, ddx of u upon v equal to denominator square, denominator into differentiation of numerator minus numerator differentiation of denominator. Practice questions which we have to solve. First question, show that the function is continuous but not differentiable. For continuity, you have to check left hand limit, right hand limit, and value of function at x equal to 1. If these three equal, it implies you can say function is continuous. Not differentiable, if you calculate left hand derivative and right hand derivative, you can observe both are not equal. It implies function is not differentiable. In solve example, I have covered this part. Second question, find the value of k for which function is continuous. And continuous means left hand limit equal to right hand limit equal to value of function at x equal to 1. In third question, again it is given as it is continuous. It implies here again you have to calculate left hand limit, right hand limit, and value of function. Since function is continuous, means left hand limit equal to right hand limit equal to value of function at x equal to 0, and after that calculate and find the value. In this pattern you have to solve and complete these three questions and submit.